In many places on Earth today, water is scarce. Climate change, as well as growing populations and land use change, pose new challenges for water management all over the world. We're going to visit one of the places where water availability is becoming ever more of a problem. This is the Guanting region in China. The area is home to over 8 million people, and the neighboring city of Beijing has one of the world's fastest growing populations. The region is already very dry, and climate change, together with the agriculture and industry needed to sustain the population, create a dramatic water shortage that will only increase in the years to come. Groundwater is heavily overused, and in 20 years, the accessible groundwater will be almost completely gone if water management does not improve. The area needs to adapt to climate change as well as sustain a growing population. But information about these important issues is hard to find, not only for researchers, but also for decision makers and the people living here. So if no one really knows what is going on, how can we work towards finding the solution? Information is the key to a sustainable future. Within the Guanting project, a model cluster for analyzing the situation has been created in cooperation with German and Chinese scientists. The cluster is very complex and contains various model components that together create an overview of the issues in the region. Let's have a look at these different components and how they work together. The climate of the Guanting region is characterized by warm summers and cold and dry winters, with a high variability of annual rainfall. As our projections show, the future climate in the region will become significantly warmer, whilst the annual amount of precipitation will not change significantly. The climate scenarios you just saw are used as input when trying to predict how water availability will be in the future. With this model, the water resources for each region are investigated. Land use and soil type are two things that affect the water resources. As rain falls, some of the water will run off directly, some will seep through the soil, and some will form interflow. Plants in the area will use some of the water to be able to grow. And finally, some of the water will evaporate, whilst another part of the water recharges the groundwater. Combining the projections for future climate change and land use change impacts at the regional scale, we get results that indicate that the Guanting area will turn distinctly drier due to warmer temperatures and intensified evaporation. The more intense evaporation will in particular cause a greater demand for water in the agricultural sector. However, in the other sectors, the pressure towards a sustainable management of water resources is also likely to increase. To analyze which measures are to be taken and what affects the water availability in different parts of the region, a water management model is used. The river system of the Guanting Basin, seen here, was integrated as a simplified river network into the model. Furthermore, the most important reservoirs, cities, water gauges, the water yield and water demands of different water user groups like municipalities, industries and farms were considered as well. We model the behavior of different water users and estimate projected water demand in different parts of the basin. The aim is to set up a water management plan for retaining a steady water supply under the given water availability. Within the catchment area, there is a transition from a near-natural discharge system to a system of rivers with lots of reservoirs and artificially managed effluents. Since 2005, the Chinese authorities have massively pushed construction of wastewater treatment plants, as marked here. This measure has improved water quality in several areas. However, agriculture is still the main cause for nutrient emissions due to extensive use of fertilizers. Beside the remaining eutrophication by nutrients, organic pollution is also still high. Trophic situations in the reservoirs range between eutrophic and hypertrophic. The most important source of nutrient contamination is given by surface runoff from rivers. Management of the reservoirs follows the requirements of flood prevention and supply of water for agriculture, industry or other users. Water level fluctuations in the reservoirs, such as periodical dry-ups, scarce water availability and nutrient contamination, are the most significant ecological stress factors in the Guanting area. When all of these different components and the information they contain are put together, the picture becomes complete. We know how much water is available in different locations, what the water quality is, and what we can expect in the future. This information can be used to plan investments in industry and urban development, decide on the locations of water treatment plants, and to set the right water prices for various water users. The Guanting project wants this information to be available for decision makers and the people living in the region, enabling them to make better decisions. Therefore, they have created a GIS-based information system where basic data and all of the model results can be searched and visualized. The project also trains students to create a more enlightened future generation, fit to deal with the challenges of water management.